Hello, dear student. How are you doing today? This is your teacher, Ms. Regine from Knowledge School. So, today's lesson is about elasticity, tension, stress, and strain. Section 2 on page 39 and 40. So you have here elastic. These slides are for information, okay? So elastic deformation is a non-permanent deformation. Deformation means changing, okay? When something change, but it's not going back to its real shape, okay? So that means deformation. The deformed material return to its original shape after the force has been removed. So for example, we have this picture. After deformation, it returns to its original shape. These are, some materials that have, these properties, okay? A plastic deformation is a permanent deformation. The deformed material does not return to its original shape after the force has been removed. Okay, as you can see here, which that material does not return to its original shape. Okay, we call it plastic deformation. We have here like a rubber band, stretch, release. Release to let it, but stretch to make it longer, and release to let it. So we have here elasticity, the ability of a body to restore its original shape after being deformed under applied force. For example, we have a rubber band and also elastic, as you can see on the picture. So you have to know the definition of elasticity, which is also on your book on page 39. Tension, the pulling force. Tension, or we can say that it is the pulling force. The force which arises in a body while being stretched or compressed. So here it is another definition of tension. It's a force that acts in a rope, string, or other object that is pulled. Any other object that you can pull it. Tension always acts along the direction of a rope. Here it is, the direction of a rope. There is a two men are pulling the rope, okay? Everyone have each person pulls with a force of 100 newtons. So the tension is 100 newton. We have here tension and also compression. Okay, when this is a string, we have a string here, and also when it goes to this side and this side, we call it tension, but we can again we call it compression. Here is another example: tension forces. Okay, so composition and tension, but both of them we call a share between them. Okay, here it is strain, also on page 40. The ratio between elongation and initial length. Elongation length, when you put something have a mass, we call it here from till here. It's not natural length, but here we call it elongation length. Okay, and also till here the initial length, but from here to here is elongation length. Okay, and it is unitless, does not have any unit. So we have here epsilon naught equals delta L over L naught, where epsilon naught is strain and delta L total elongation, which the unit is meter, and L naught original length, which is the unit is meter, but there is but the sigma, which is strain, does not have a unit. Here it is the stress on page 40. The force applied on a unit area of a cross section of a wire. Okay. So student, take a look to the number 1 picture. Here it is number 1, here it is number 2. Okay, so we have a stress here equals force over cross section area. No matter, let's say tensile stress, we have a compressive stress. So if this area is, whenever it's more, the biggest area, the stress will be a smaller. Okay, so we have here force over cross section area. This is the formula of stress, and the unit is N over N power 2. Here we have sigma, which is stress F over A. F is applied force to the unit N, which is Newton, across sectional area, which is the unit M power 2. Okay, here it is. We have here normal stress. We have here shear stress. Normal stress, compression. We have a compression here, okay? Here we have shear stress too. Stress, shear stress. So we have here stress, for example. We have here stress, normal stress, twice the stress, okay? And strain it, twice the strain. So stress and strain are kind of like, they are, they are pretty different, okay? So here it is, the difference between stress and strain. This table is so important, so try to write all notes on your notebook, and also you have to keep this table, okay? For the difference between stress and strain, which stress is the restoring or deforming force per unit area. Strain is the change in shape per original shape. So you have to know their formulas, and also you have to know their units, which strain does not have a unit. Okay, students, this was the end of our lesson, so good luck.